Okay, so we talked about isotopes last class, and that's protons and neutrons, right? Today we're going to be talking about ions, and ions are atoms that have an unequal number of protons and electrons. Okay, so the number of protons and electrons are going to be different. Okay. And now, if an atom has more protons, right, that's more positive energy, it creates a positive charge. And we call positive ions cations. Okay. So positive ions are called cations. And then the opposite is true as well. If you got more electrons than you got protons, you got more negative energy. And so ions with more electrons have a negative charge, and those are called anions. So cations and anions. So easy way to remember this is if you like cats, cats are positive. And just remember that the first girl that broke Mr. O's heart in kindergarten's name was Anne. She's negative, okay? So bad Anne. Cat good and bad, okay? Okay, so we got two examples right here. We got a sodium atom on the left, and if you take a look, a regular sodium atom has 11 protons, 11 electrons, right? But if it loses an electron, now we have more protons. And since we have more protons, it's going to have a positive charge. Since you have one more proton than electron, the charge is going to be +1, okay? And then vice versa is true as well. Any questions? Hopefully this is review from your previous chem classes, right? Okay, so those are called ions. All right, so when you have an ion, that's only one element, right? So like the sodium ion we're looking at right here, the chloride ion we're looking at here, those are called monatomic ions. Mon because mono means one, so one atom, monatomic. Those are monatomic ions, okay? But there are ions that are formed by multiple atoms. So there are these molecules called polyatomic ions, and that's why I told you guys to pull up that chart. And polyatomic ions are basically just molecules that have a charge. So when these atoms come together, they form this molecule, and they tend to have a specific positive or negative charge to it. And those are called polyatomic ions. So if you guys haven't already, you guys can go to Canvas and pull up the polyatomic ion chart. It's under important resources. If not, that's fine. There's one at the bottom of this document, so we'll get to that. But I do want to talk about this chart real quick because you do need to memorize a couple of them, okay? Just because we'll be seeing them so much. All right, so let's take a look at the polyatomic ions. Okay, you click right here, polyatomic ion chart, and you have this big chart here. Now, you do not, whatever. You do not need to memorize all of these. I'm going to be honest with you guys. I don't even have all of these memorized, okay? Okay, however, the ones that have a star next to them, I highly, 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 highly recommend that you guys memorize it. So I know you guys can't really, you might not be able to see it on the screen, but if you have it on your Chromebook, and I have this in the class notes as well, but whatever has a red star next to it, I do recommend that you guys memorize them because you're going to need to know them for the AP test. They come up very often. And then on your exam, we're going to have some naming, and you're going to need to know the names of some of the ones that I've starred. But the ones that I haven't starred, you don't really need to memorize them, okay? Okay, but these function pretty much the same thing as the regular monatomic ions. These are just groups, and these guys like to stay together. Okay, we don't like to break them up. Okay, any questions on polyatomic ions? It's just a molecule that has a charge. Okay, so let's go back to our notes. So I want you guys to take out your periodic table today because I'm going to show you guys a very quick way for you guys to figure out what charge certain elements like to have. Okay, so elements, they like to form a specific charge. So we call this the most common ion. I usually abbreviate it as MCI, but elements, they like to turn into the same ion most of the time, okay? And we call that the most common ion because the ion that they're most commonly found as. Okay, and on the periodic table, the pattern is really easy, okay? You only really need to count to 4, okay? So this first column right here, 1A, where hydrogen starts, everybody in this column right here, they want to form a +1 charge. Okay, so if you guys take a look at your notes, you guys should see lithium wants to be +1, sodium wants to be +1, so on and so forth. So on your periodic table, on top of the first column, you guys can write +1. That way, it's just an easy reminder that everybody in that column, they want to basically lose an electron. So +1, these guys lose 1 electron. All right, second column, it's kind of follows a pattern. These guys right here, they want to lose 2 electrons and they turn +2. So Mg becomes +2, calcium becomes +2, so on and so forth. Beryllium also wants to be +2. I don't know why that's not in there, but okay. All right, so if you guys notice on the periodic table, you got these 2 high columns, and then you got this lower section right here. These are called the transition metals. And these guys right here, these guys don't really have a pattern. So you guys don't need to memorize any of these MCIs because they don't really have an MCI. So for example, we got something like iron. Iron likes to be 2+, 3+. Sometimes you'll find it in 4+. Okay, so a lot of these guys in the middle, they have multiple ions. You don't need to memorize what their most common ion is because they don't really have any. Okay. Okay, and then we skip this middle section with the transition metals, and then we go to this column right here, 3A. These guys are very simple. They want to become +3, so they like to lose 3 electrons. Okay, 4A right here. Technically, the most common ion is -4, but usually they form a different type of bond, and so we can kind of just ignore that for right now. But you can write -4 if you'd like. And there's a seat right there in the 3rd row. Yeah. All right, and then from there, it gets pretty simple. So this column right here, -3, -2, -1, and then this last column, noble gases, these guys have no MCI, okay? These do not like to form charges. In fact, they don't really like to react with anything at all. These are the loners on the periodic table. They like to be alone, okay? And so the pattern's really easy for you guys to remember. It's +1, +2, +3, -4, -3, -2, -1, and then no MCI. Okay, and you will be expected to know that for your exam next week and for the AP test as well. This is just kind of a gimme. Unfortunately, there's never going to be problems like, oh, what's lithium's MCI? That's too easy. We just assume that you know it in other problems. Okay. All right, any questions about MCIs, polyatomic ions? Yes. It's technically -4, yeah. But honestly, you don't really need to remember that. I just like putting it in there so you remember that it's sequential, but it is technically -4. Good question though. All right, so real quick, I want you guys to take a minute. I want you guys to. I haven't taught you guys this yet, but I want you guys to, based on the pattern, I want you guys to figure out the MCIs for gallium and phosphorus. Write it down on your paper. Check with the person next to you, make sure they got it right, and then we'll go over it in 1 minute. Alrighty, guys. So let's go over the problem 2.12. So if you guys pull out your periodic table, we're going to look for gallium and phosphorus. So gallium is right here. So if you guys can show me with your fingers, what is the MCI for this? What's the charge? Yeah, 3, positive 3, right? So gallium is going to be positive 3, okay? And it's because it's in this column, the positive 3 column. All right, and then phosphorus, very simple, same thing. It's in the negative 3 column, so phosphorus is going to be 3 minus. Okay, and that's it. Just to let you guys know, the ones down here get a little bit complicated, but we don't really look at those. And usually if we look at ions from that section right there, the charge is given to you. So you don't really need to worry about that. But just be aware, the ones down here, they don't really follow that pattern. The ones up here will. Okay. All righty, let's continue. So that's MCIs. Okay, so we're going to talk about different types of compounds now. So the main types of compounds or molecules that we'll be seeing in AP chemistry are called ionic and covalent compounds. Okay, ionic and covalent compounds. Now, I do not want you guys to copy this down. This is just here for your notes. I'll tell you guys a simpler way to copy down the definitions. But I'm going to talk about the difference between ionic and covalent. And it's super duper easy. Okay. All right. So ionic compounds. It is usually formed by a metal and a non-metal. We haven't talked about that yet, so I'm not going to assume you know that yet. But easy way to think about it, it's basically a cation plus an anion. Okay. There could be multiple. So you could have like 2 cations, 1 anion. 1 cation, 2 anions, and whatever. But it's when a cation and anion, the positive and the negative energy, the opposites attract, and then they get married, and they become an ionic compound. All right, and then the second one, covalent compounds. This one is going to be a non-metal and a non-metal. So just know that for this one, there are no ions involved. Okay, so covalents have to do with non-ions. So if you have like a polyatomic ion and a cation, it's not going to be a covalent compound. Okay, so just ionic is cation plus anion. All right, so we're going to talk about how ionic compounds form. It's very simple. We looked at these 2 examples earlier, but we said that sodium likes to form a positive 1 charge. Yes. Yeah, covalent and molecular are the same term. Thank you, sir. I should have mentioned that. Thank you. You guys might have seen this in your textbook or maybe online, but these are also called molecular compounds. Okay. Thank you. Yeah, covalent and molecular are the same. Yes. Mm-hmm. No, because the polyatomics are involved. I'll show you an example after this one in a second. But the reason why I don't like saying metal and non-metal is because people just automatically look at the periodic table. But sometimes the cation could be like ammonia, so polyatomic NH4, and that's not a metal, right? So that way it's an ionic compound, but it's not a metal and a non-metal specific. But just usually. Okay, so quick example of a ionic compound. If you have sodium, it likes to form a +1 charge, and a chlorine, it likes to form a -1 charge, right? And if you guys notice, these are opposite. So they get very, very, very close, and then they combine to form NaCl, and that's an ionic compound. So this is your ionic compound. The positive guy right here is a cation, and then the -1 right here is an anion. All right, so let's take a look at an example of one where it's not going to be a metal and a non-metal. So let's say, for example, right here, instead of sodium, we had ammonium, which is NH4+. Now, if you guys look at this, this is not on the periodic table, right? This is polyatomic, so it's a molecule. So this isn't a metal, but it's still a cation because it has a positive charge. And then let's say, for example, our anion right here is going to be SO4 2- sulfate. So if you guys notice, this is a positive charge and this is a negative charge, right? So they're going to be attracted to each other. But if you guys notice, sulfate has a greater negative charge than ammonia's positive charge, right? So sulfate is too much for ammonium to handle, right? It's too much negative energy. This guy's too sad. So what ammonium has to do in order to make an ionic compound is it needs to find a friend. It needs to find another ammonium. So you need two of them to balance out the sulfate. Okay, so the ionic compound you form is going to have ammonium. So we're going to write NH4. It's going to have sulfate. So we're going to write SO4. But since you need two ammoniums, we're going to put that in parentheses and put a 2 behind it. Okay, so this is the ionic compound that will be formed when you combine ammonium and sulfate. Okay, so the key thing is you just need to make sure the charges balance each other out. Okay. And that's pretty much how ionic compounds work. All you're trying to do is balance out the charges. Yes. Not on this test, no. Yeah. Alloys, you might get like one question on the AP test every like 2-3 years. Yeah. All right, any questions before we do some practice problems? Okay. All righty, let's do a couple practice. So let's start nice and easy. I want you guys to do 213 on your own. And for this one, we have a bunch of different molecules. I'm sorry if this is kind of hard to see. Just make sure you have it on your Chromebook. That way you can zoom in. But you have 6 different molecules. And I want you guys to just write down on your paper, is it ionic or is it covalent? Okay, that's pretty much it. Just a hint, you will have a question like this on your exam. So it's a little good practice for it. Okay, so just identify if they are ionic or covalent. I'll give you guys about minute 30 to do this, and then we'll go over each of them. All right, so the first one, N2O. If you guys notice, nitrogen and oxygen are both nonmetals, right? So this is going to be covalent. Okay, yes. Are you talking about the covalent ones? The ones with, yeah, the covalents aren't going to be balanced in terms of charge. Yeah, covalents have nothing to do with the ionic charge. Yeah, but good point on that. Yes. Yeah, I think it's in unit 1, but easy way to look at it is if you look on the left side of the periodic table, or left and middle, those are metals. And then on the right side right here, those are nonmetals. Yeah. Okay, so yeah, nitrogen and oxygen are both on the right side. So since they're both nonmetals, this is going to be covalent. Okay. All right, Na2O. If you look, sodium is a metal, so it forms a cation, right? It forms Na+. Oxygen is a nonmetal, so you got a positive and negative, so this is going to be ionic. Okay, same thing right here. Ca is a metal, it's on the left side of the periodic table. Cl is a nonmetal, it's on the right side of the periodic table. So positive and negative, this is going to be ionic. If you look here, S is going to be on the right side, it's a nonmetal. F is also on the right side, it's a nonmetal. So 2 nonmetals form covalent. Okay. If you take a look right here, Mg, this is going to be a metal, right? And it forms a +2 charge. If you look at PO4 though, I know we just looked at a couple minutes ago, but PO4 is phosphate. It's a polyatomic ion, right? Okay. And if you look on your chart, PO4 is 3-. So you got a positive cation and a negative anion. So since you got 2 ions, this is going to be an ionic compound. Okay. So this is why it's important to memorize the polyatomic ions. That way you can just look at the molecule and be like, hey, this is a polyatomic. Okay, but an easy way for you guys to notice is that if there's a polyatomic, there's just going to be a lot of elements in that molecule. Okay. All right, and then the last one right here, this one's the one that's a little bit tricky. A lot of people take a look at this. They see nitrogen, they see chlorine, they say, hey, these are both nonmetals, so it must be covalent, which is half true because these are both nonmetals. But if you take a look right here, NH4 is actually a polyatomic ion. NH4 is ammonium. It's NH4 plus. And it's combining with one chlorine, which forms a minus charge. So you got a positive and negative. So this is actually going to be ionic. Okay, so that one is kind of a tricky one, but just keep an eye out for that. Ammonium kind of messes things up because it looks like it's covalent, but it's going to be a cation. It's going to be a polyatomic ion. Okay. Yes. I give you a new periodic table for the exam, but on yours you can write whatever you like. Yeah. Actually, guys, I'll be very nice. I will let you guys write down the polyatomic ions on your periodic table, and you can use your own for the first exam, okay? But only if you guys promise to memorize them. Does everyone promise? And nobody here has ever lied, right? Okay, all right. I'm being very nice this year. Okay. Any questions on covalent ionic? All right, let's go to 214. Okay, but that's the only thing you can have on your periodic table, okay? Only the polyatomic ions, okay? I'm going to check everybody's periodic tables during the test. And if there's something else, then I will fail you, okay? All right, let's take a look at 214. So we're going to write down the compound formed by the two ions. So I'll do A with you, and then you guys can try B, C, and D on your own. But very simple, it's what we did earlier, okay? We have Al3+, and you got Cl minus, right? So you got a positive and negative, so they're looking at each other, and they're attracted to one another, right? Okay, but the problem, if you guys notice, is that aluminum is way too positive, right? It's the person that's way too happy. So chlorine can't deal with all that happiness. So chlorine needs to bring in some more negativity into the compound. So since it's +3 and this is -1, you're going to need 3 chlorines in order to balance out the 1 aluminum. Okay, so you got 1 aluminum and 3 chlorine. So the compound that you make will be AlCl3. Okay, and that's pretty much what I want you guys to do for the other example. Okay, just figure out how many of each ion you need, and I want you guys to write down the compound that you're gonna, the molecule that you're gonna form. Okay, so I'll give you guys about 2 minutes to do the next one, the next B, C, and D, and then we'll go over them together. And then I think we go on to the last topic for this unit. We're almost done. All right, so for the next one, you got Al3+, and you have O2-. Okay. Okay, so for this, hopefully you guys identified that you need 2 aluminums and 3 oxygens. That way you get a total +6 and -6 charge to balance each other out. So you get Al2O3. Okay. One thing I do want to mention is just make sure that on the ionic compound, there's no positive or negative charge. Okay, once they balance each other out, we don't write that on the notation. Okay, you just need to write the small numbers, the subscripts on the bottom. All right, so for the next one, you got to actually go to the periodic table and look at the pattern for the MCIs. If you guys take a look, Mg has a MCI of +2. Phosphorus has a MCI of 3-. Okay, so same thing right here as the previous one. You need 3 magnesiums 2 phosphoruses. So it's going to be Mg3P2. And that's going to be your ionic compound. All right, and then for the last one, we're using Mg again, so that's going to be 2 plus. Okay, your anion is a polyatomic this time. It's NO3 minus nitrate. Now, you guys should notice that you need 2 nitrates in order to balance out the Mg. So it's going to be Mg and NO3, but since this is polyatomic, you put it in parentheses and you put a 2 behind it. Okay, and there you go. Those are the formulas for polyatomic ions. You will have problems on your exam where you do need to write down these formulas. Just make sure you're comfortable doing it. I think your homework has a bunch of problems. I think unnecessarily a lot. So you will get a lot of practice for this. Yes. Yeah, the polyatomics will always have the same positive and negatives. Yeah. So like nitrate will always be negative. No tricks. Yeah. If you have multiple of them. So for example, this one, you need 2 nitrates, right? But if there's a situation you only need 1, so like with Na, you just write it without parentheses. Yeah. I won't dock you if you put parentheses here, but the AP graders might make fun of you. Yeah. Great questions. Any other questions? All right, let's go to the last topic, and this is not that fun, to be honest. It's naming, it's nomenclature, it's how to name these ionic compounds, okay? Now, we're gonna go over a couple of the rules. There are a lot of rules, but some of the rules are just nerd stuff. You don't really need it. For the AP test, you only need like 3 or 4 of these. So I'm gonna go over those ones. You will be expected to know these rules and how to use them. I'm not gonna let you write it on your periodic tables. Just make sure you're comfortable using it. And there's a lot of problems on your homework, so you should get a lot of practice. But let's go over how to name ionic compounds. Okay, so we said that an ionic compound is always a cation plus an anion, right? So first rule, if the metal forms only one type of cation, basically if it follows the MCI pattern. So if you have something in this column, like K, right? K is always positive 1. If you have calcium, always positive 2, so on and so forth. If the metal always forms only one cation, all you have to do is write the name of the metal. Okay, so here we have an example with KCl. Okay, K only forms K plus, right? There's only one charge that it makes. You just write down the name, potassium. Okay, so if it only forms one ion, the metal, you just write down the name. And then the second part of the name is the anion. Okay, so the anion, you just need to change the ending to IDE. Okay, so here we have potassium and chlorine, right? This is chlorine. Okay, but for the ionic compound name, we change the ending to chloride. So the name of the molecule KCl is potassium chloride. You write the name of the cation, and then the anion, you just change the ending to IDE. Okay? And that's it. That's the first rule. All right, let's see if you guys can try one on your own. This is going to follow the same rule. We have CaBr2. Okay, so work with the person next to you. See if you guys can take a minute to figure out the name of CaBr2. And then we'll go over it in 1 minute. Okay, so you got Ca, and the name for Ca is going to be calcium. Okay, and Ca is in the section on the periodic table where it follows a specific pattern, right? It's always +2. So this guy's name is just going to be calcium. So we're going to write calcium. Okay, if you look at Br on the periodic table, Br's name is bromine. But then we need to change the ending to IDE. So it's going to be calcium bromide. And there you go. That's the name for this ionic compound right here. Okay? Just write the cation and then the anion, IDE. Any questions on that first rule? Okay. If you write the wrong ending, so I've had people write like oxide, it's oxide, but if you write something like oxide, that's fine. It's not too big of a deal. So if you change, as long as you remember the ending is IDE, I will give you credit for that. Just make sure by the AP test you're familiar with the endings, okay? All right, let's go to the second rule. The second rule is pretty much the same thing as the first rule with one addition to it. Okay, this is for metals that form more than one kind of cation. Okay, so I'm talking about the transition metals, the ones in the middle that don't follow a pattern, okay? And I think it's easiest if we do an example as we go through it, okay? So let's take a look at this example right here, FeBr2, okay? So FeBr2. Okay, so Fe is iron, and it's in the middle of the periodic table, so we don't know what its charge is, right? So what we have to do for these ones is we actually need to calculate what the charge of the metal is if it doesn't follow a pattern. And the way that we calculate is very simple. We just look at the anions that it's attached to, okay? So I want you guys to go on your periodic table and look for bromine, Br, and just on your paper, just write down what is the MCI for bromine. Okay, just write down the MCI for bromine. Okay, hopefully you guys are able to find bromine, and bromine is in the -1 column, right? So bromine is going to have a charge of -1, okay? So going back to this compound right here, we have iron, which we don't know the MCI of yet, or the ion charge yet, but we know that bromine always forms -1, right? And so if there's two of them, that means combined they have a total of -2, because there's two. And there's only one iron, right? So that means the iron has to balance out the bromines. So that means that this iron has to be +2 to balance out the two bromines. Okay, so that's how you can find out the charge, even if it has to do with a metal that doesn't have an MCI. And then for the name, it's very simple. It's the same thing as before. You write the name of the cation, which is iron. The only difference is, since we don't, this one doesn't have an MCI, we have to write the charge of iron in parentheses next to it in Roman numerals. Okay, so this one is called iron 2. And then you just get bromine, you change the ending to IDE. So it's iron 2 bromide. That's how you write the name for these types of compounds. Okay. So just one more extra step, you got to do a calculation and write the Roman numerals. Okay, so we got another example right here. Same thing with iron, but this one is connected to 3 bromines, right? So this one is -3. That means this iron has to be +3. And so the name of this iron is iron 3 bromide. Okay, so that's the only real difference. Any questions on that? Hopefully it's not too bad. All right, I will give you guys 2 minutes. I want you guys to find out the names of those two compounds right there. I want you guys to do A and B. Yeah. You do get a periodic table. Yeah. It'd be impossible to do it without it. Yeah. One thing I do want to mention is sometimes you will see different names for these ionic compounds. So sometimes you'll see terms like chromis, cobaltus, cuprous. Hey, but if I'm just being honest with you, this is literally just boomer stuff. Only the really old chemists still use this. Everyone pretty much uses what we've been learning with the parentheses. So if you ever see something like this on a practice problem, or you won't see it on my test, and I don't think they even show it on the AP test anymore, but if you ever see something like this, ferrous, stannous, just know it's just the boomer name for these compounds. Okay, you don't need to memorize them. Okay, I don't even know them, just being honest. All right, now last rule. This has to do with polyatomic ions. Just make sure you guys have them available somewhere. When you have polyatomic ions in your ionic compound, it makes the naming really easy, because all you need to do is write the name that's on the chart. Okay, so we'll do an example real quick. So we got FeSO4. Okay, so if you look at iron or Fe, we already talked about in the previous examples, this is iron, right? Yes. You know where next door. Yeah. Okay, this is iron. And we actually need to figure out the charge for this one, right? Because iron's in the middle of the periodic table. So we're going to have some parentheses. We don't know the number yet, so we're just going to leave a question mark for now. Okay, but we have this as our anion, a polyatomic ion. So if you go to the periodic table, or sorry, not the periodic table, your polyatomic chart, and you look up SO4, you're going to see that it's sulfate, right? And it's -2. So for the name, it's really easy. Just write sulfate. Don't change the ending. Don't do IDE. Don't add anything. You just write the name. Okay, and all you know is this is -2, which means since there's one iron, this has to be +2, right? So that means in the parentheses right here, we just do a 2. So this compound's name is iron 2 sulfate. And that's it. Polyatomics make it really easy. You just write the name. Don't do anything to it. All right, I'll give you guys about a minute 30 to do 2.17. You'll need the polyatomic chart, so just make sure you have that available somewhere. And again, just write the names if there's polyatomics involved. Okay, take about a minute and a half. Try that out. We'll go over it, and then we will take our break, and then we'll do a quick practice for the exam. Okay, so for this compound right here, hopefully you guys are able to identify that the cation is going to be NH4, and then the anion is NO3. Okay, if you guys go to the polyatomic chart up there, I'm not going to scroll up, but hopefully you guys can. NH4 is going to be ammonium, and NO3 is going to be nitrate. Okay, so your compound's name is ammonium nitrate. Super simple. Okay, and congratulations, guys. That is your first unit of the year in this class. Great job, everybody. Yes. Nope, not for polyatomics. Polyatomics, you literally just write the name. Yeah. For this one, it's because iron is on the periodic table. It's in the section that doesn't have a MCI. It's in the middle right here. That's why we did it. Yeah, parentheses are only for the middle section elements. Polyatomics are just on this chart right here. Yeah, so if it's on this chart, it's a polyatomic. And if it's on the periodic table, you just use the periodic table. Alrighty, guys, let's take a quick, we'll do 5 minutes today, and then we will come back, and then we will do the practice exam. Okay, so we have the mass spectra for this molecule, SO minus. We have an ion, so we got SO minus. And here, the key thing is we're going to assume oxygen has only one isotope of oxygen 20. That means every single oxygen is going to be oxygen 20. You have a question? Sorry, my bad. Okay, just keep that in mind. That's the important thing. All the oxygens are oxygen 20. Okay, so based on the mass spectra, what are the, what are the 4 possible masses of sulfur isotopes in this sample? Okay, so if you guys remember, mass spectra basically tells you the mass number, right? So at the very bottom, these numbers right here are pretty much telling you all of the protons plus the neutrons combined. Okay, so far so good? Okay, now, the reason why this mass spectra is a little bit different is because usually, or in the previous examples, we've only talked about one element at a time, right? Okay, but this one is a molecule, right? So there are 2 molecules involved. Okay, which means that every single one of these, every single one of these columns are telling you the combined weight of S plus oxygen. Okay, so these bars are telling you the mass of S plus oxygen. Okay. Make sense? Yes. I'm sorry, I didn't hear it. 5, thank you. I can't count. I'm sorry, guys. Very early for me too. 5, thank you. Yes. 2, 3, 4, 5. There's 5 columns, so it's gonna be 5. Yeah, that was my mistake. Yeah, sorry, guys. I'm still waking up. So let's take a look. Let's do one of these together. So let's take a look at the smallest line. Oh my, this is so distracting. Okay, so this bar right here, the total mass is going to be 89 AMU, right? So let's write that down on our papers. 89 AMU. Okay. So we just said that the bar is going to give you the mass of the sulfur and the mass of the oxygen. Okay. So basically, we need to figure out what the mass of the sulfur is. Now, if you guys take a look at the instructions above, it tells you that oxygen only has one isotope, right? And what's the isotope for oxygen? 20. So that means that oxygen right here, this is going to be 20 AMU. Okay, which means it's very easy to find the mass of the sulfur isotope, right? Okay, all we have to do is subtract 89 and 20. That means that this column right here, the 89, it is made out of oxygen 20, and it's combined with sulfur 69. Nice. Okay, makes sense. Also, that number was not planned. Just happened that way. All right. Any questions on how to find the AMUs for mass spectra with multiple elements? You guys are good? Yes. Pretty much, yeah. Yeah, of course. I'm recording this, but you guys can take pictures. Just please don't take pictures of me, but screen is fine, yeah. No, it's just for you. Yeah. Pretty much, yeah, because all of the oxygens are 20, so yeah. So the sulfur is the only one that's going to have some variance. Okay, so I'll give you guys a second. I know this is pretty easy, but I want you guys to, you don't have to do all 5, but I want you guys, whoa, okay. Freak me out. Okay, I want you guys to find out the mass of the sulfur for the most common one, because that's what we're going to be doing for part B. So take a second to try the one for 91, figure out what the mass number for the sulfur is there, and then we'll move on to part B. Okay, so pretty simple. 91 minus 20 is going to be 71. So this one is going to be sulfur 71 and oxygen 20. Okay, everybody good with that? Okay, so I'm going to erase this part right here, part A. And if you take a look at part B, though, it's asking how many neutrons does the most common isotope of sulfur have? Well, if you take a look at our mass spectra, we have a bunch of different bars, right? The tallest bar is the most common one, right? So this tallest bar tells us the most common isotope, but this is talking about SO minus. We just figured out that it's sulfur 71. Okay, now if you guys remember, this number back here is going to be protons plus neutrons. Okay, so if the question is asking how many neutrons does the most common isotope of sulfur have, all we have to do is subtract the protons, right? So to do this, you just need to figure out how many protons sulfur has and subtract from there. Okay. So I'll give you guys a second to try that. So take a look at your periodic table, see if you guys can figure out how many neutrons the most common isotope of sulfur has. All right, guys. So hopefully I wasn't too bad. If you take a look at the periodic table, sulfur has how many protons? Yes, 16. So in order to find the neutrons, you just do 71 minus 16. That'll give you 55 neutrons. Okay. All right. Any questions on how to find neutrons? Well, not too bad. All right. We're gonna look at C real quick. I'm not even gonna finish the problems, just so that we can start packing up. But let's take a look at C, and I'll get you guys started just to get your brains thinking, and then we'll finish up. Okay. So if you take a look at C, it's asking us, does the negative charge on the ion affect the spectra? Okay, so here we're looking at the ion SO minus. Okay, so it has a negative charge. Now, I want you guys to just think about what causes something to have a negative charge. Okay, you don't need to say it out loud, just think about it. Okay, so what causes a negative charge? Okay. Okay, now, with that in mind, let's take a look at the spectra. If you guys take a look at the spectra, here we have the percent abundance. We have the AMU, and if you remember, AMU is protons plus neutrons, right? So all the bars that we have, that tells us the protons and the neutrons. And so the question is basically asking, is whatever causes the charge going to affect the height of the bars right here? Okay, and I'm not going to answer that for you guys. You guys can kind of think about it, talk about it, ask ChatGPT about it, but I'll kind of leave off there. Okay. Yes. Yes.